Hello, this is the second part of Chapter 2 about conditional probability. In the last lecture, I have introduced the definition of conditional probability, and I gave you several examples where the conditional probabilities are more appropriate, especially to compare two different groups or to study the relationship between two variables. So we learned the definition of conditional probability, and we learned the definition of statistical independence, and also we learned multiplication rule, general multiplication rule and special multiplication rule. These are very useful and important concepts throughout statistics and any application of statistics like to social sciences or any applications. So today we are going to continue the study about conditional probability, but what's interesting today here is a little bit different. Two main topics today is that first, suppose that the information is given in the form of conditional probability. So we know the conditional probability, but we are interested in a different type of probability, like unconditional probability, or we would like to switch the condition and the main event. So in these cases, how can we handle or how can we obtain the probability of our interest from conditional probabilities? So in the previous part, we learned how to obtain conditional probability, but now, today, we are going the other way. We know the conditional probabilities, and how can we obtain something else? So I prepared an example about manufacturing quality control, and consider an example. Suppose that a smartphone manufacturer is concerned about defective batteries. I was inspired by the battery problems in Samsung Galaxy a few years ago, but it's not related to that smartphone or batteries at all. Just a simple example. Suppose that what we know, so the information we know first. So imagine that you are the manager of this quality control problem. So suppose that what you know is that first, 60% of batteries are domestically supplied, and the other 40% of batteries are imported. So, and we are going to define notations in this way. Unfortunately, defective and domestic both start with D, so I am going to use D for domestic ones. So D stands for a battery is domestically produced, and the complement means the negation, so imported. And defectiveness is denoted by F instead of D. So say a battery fails, so I will call this just fail. Then, in this case, also you know that 2% of domestic batteries are defective, and 7% of imported batteries are defective. So the defect rate is different between domestic ones and imported ones. And now, the first step, how can you summarize this information in statistical notation? So there are 5 options. Think about this. I'll give you a few seconds, or you may pause the video now and think about this. You understand what these two sentences mean, so you should be able to write them in probability notation. Okay, pause it, and I'm going to give you the answer now. You have to understand the sentences in this way. I said 2% of domestic batteries are defective, which means, like, if you write it as a full probability statement, I would say this as probability of defect given that a battery is domestic is 2%. So the hidden implicit terms are, actually you should say this conditional probability of being defective under the condition that the battery is domestically supplied, right? That's the meaning of this. Or you may imagine the underlying experiment. So when you choose batteries at random, but you choose only among domestic batteries. So here are a pile of domestic batteries, and you randomly choose and inspect. And if it's defective, check it out. If not, no. And by doing that, from that experiment, what you get is a domestic, like conditional probability, because when you randomly choose one, you already know that the chosen battery is domestic, or you are choosing from only domestic batteries. So clearly the condition is being domestic, and the main event you are interested in is defectiveness, whether the battery is defective or not. Similarly, 7% of imported batteries are defective. In this statement, the condition, what has already happened, is being an imported battery, right? A battery, you randomly choose an imported battery, and then check if that battery is defective or not. So the first part, what you know when you choose the random battery is being imported, and what you are curious about, what you actually check about, inspect on the battery, is whether it is defective or not. So condition is the complement imported, and the main event of interest is whether it fails or not. So these two are, the answer is C. C is the answer, right? Okay, now then we have, that's all we have. So our informations are 60% are domestically supplied, and then 40% imported is actually the same information as 60% domestic, right? If you know that 60% are domestic, automatically it implies the other 40% are imported. So I will treat these two numbers, 60% and 40%, as one information. That's one thing. And we have additionally have two conditional probabilities. That's all we have, three informations. And from there, what we want to calculate is, for example, things like this: overall defect rate. As a consumer, I don't know, I don't care if the battery is imported or domestically produced. What matters is whether it is defective or not. So I'd like to calculate the overall probability of defect. And also, it will be interesting to see overall probability, the probability of being domestically supplied among defective ones. So then, in any case, we do not have these informations, but we do have enough information to calculate them. I will show you, and more fundamentally, what we are going to do here is, if we could fill out this joint probability distribution table, then there is no problem. Or if you could fill out a frequency distribution table like that, or then from this table, you can calculate any probability. So you may understand the problem in either way. You may want to calculate these, or you may want to obtain these numbers, fill out this table. So not a problem. So I am going to show you an interesting method, a specific method which is very intuitive and easy to understand, but very powerful and can be generalized to many applications. And I'm going to stop this video here and continue in the next video about that method.